Everyone. So I am Arvind Akshan and I work as a solutions consultant at AccelEdge. So the topic for today's webinar is demystifying pipeline observability. I'll move on to the next slide. Pradeep has actually introduced. We'll be conducting the session today. I'll move on to the next slide. Coming to the agenda for today's session, we'll start off with the pipeline observability overview, where I'll explain you what is pipeline observability in terms of accelerators terms, and I'll move on to the capabilities or components. I'll be explaining the different topics that exist within pipeline and um, how it can help you in observing, right? So those things will be covered in topic two. The third topic will be benefits of pipeline observability, where I'll explain the benefits and how it can help when you implement within your data landscape. And the topic four is very important, right? So there I'll be covering the different ways using which you can implement pipeline observability in your data ecosystem. Um, Followed by the topic four, I'll quickly show you a demo and final question and answer. So these are the agenda for today's session. So we'll move on to the next slide. Um, so pipeline observability overview, right? So it provides a complete view into the performance and health of an organization's suite of data pipeline, and it also includes relationship to and quality or reliability of the data assets they can generate. So let me move on. So these are the glossaries, right? These are the glossaries that we will be frequently using when I'm going to explain many key concepts within pipeline. Um, Starting from pipeline itself. So a pipeline, it is a base entity in Excel data, and each pipeline can have executions, metadata, metrics, which are encapsulated and used for exploration and monitoring. So moving on to the next glossary, which is data asset. A data asset in Accelerator, it can be a table or file or column or database or schema. So in anything of that sort, we refer to as a data asset. And third one is job. Um, the job nodes represent the execution steps in a data pipeline, such as like a reading it data from a table or a file, or writing something to a table or a file, or doing some sort of process, right? Process related to your pipeline. So those can be termed as jobs. And moving on to the spans. So spans are used to provide more granular details about a job. So you can also have a child span within a parent span, and there can be like many child spans as well. And one thing that we have to remember is each jobs will have a corresponding span to it. And it helps in understanding the timeline that has taken for a particular job to complete. Moving on to the final thing, events. A span is always associated with an event, and we can use multiple key value pairs to raise events. And these events must be fired within a span or a child span. Moving on to the next slide. Now we'll go through the capabilities or components that are existing in the pipeline, right? Pipeline observability. So let me move on. So the first step is, as you can see, the pipelines and pipeline run itself. So this is how the pipeline page looks like. So it provides a single pane of glass for an organization's pipelines view, regardless of where it is running. So it can run on Airflow, it can run on Databricks, or it can be like a Python code, or it can be Autosys. So you can have your pipeline code anywhere, and you'll be still able to observe and view the pipeline executions. And as you can see over here, it will list all your pipelines, and you'll be able to see the status, successful, like the status of the pipeline as well, like success, failure, running, and what are the alert severity that are being generated from the pipelines, ranging from critical, high, medium, low, and the alert type, all policies. So this helps us in identifying or looking at the pipelines at a high level. So it is really a key thing, right? And also, as you can see, uh, like there can be like multiple pipelines, and each pipeline can represents the process of sourcing, transformation, or writing into some data assets. And within each pipeline we can have like monitoring and reporting. So when I say monitoring and reporting, it captures the execution history. Each time we run the pipeline, the execution is captured, and we'll also be able to capture other metadata or metrics related to the pipeline execution. And it helps us in monitoring the performance of the pipelines. And the third one is pipeline runs. So each time you run a pipeline, that the execution history is stored. I think that is all that I explained already. And the fourth one is insights. So within each run, you will get various types of metrics, monitors. You will be able to see the timelines of each of the jobs spans at a detailed level, which will further aid in understanding how your pipeline works and and if it is meeting the SLAs. And the current support, so it's focused on batch pipeline executions. So moving on to the next slide. So once you click open a pipeline from the AccelEdge UI, this is the page that you will land on to. So as you can see, there are some white boxes, there are some blue boxes, right? So the blue boxes represents the asset node. So it can be like a physical asset such as like a table or file. And we can also onboard this in Axel data using the out of the box connectors that are available. So currently we have close to 42 connectors to connect to various data source like file system, relational table, or structured database. So you leverage those connectors and onboard these assets. And the white box here, it represents the job node. So this job node can represent the execution steps in a data pipeline, like reading, writing, or doing some sort of intermediate processes within your pipeline itself. And you will be able to stitch the lineage between the jobs and the assets, thereby showcasing an end-to-end pipeline view of how your data is traversing from source A to source B. So that is the significance of pipeline. Adding to that, here on the top, you will be able to see the time that has taken for current pipeline run, as well as the different execution history. So you will be able to navigate back to the previous execution history, compare it to the current execution, and you can also configure data reliability policies within your pipeline. And if you have configured it, you'll be able to see the number of policies configured from here. So that is about the pipeline graph. Moving on to the next slide. So as you can see in the slide, so these are nothing but spans. So each jobs will have a span. The span represents the timeline that a process has taken to complete. As you can see, this ad hoc API demo. So this is the root span of the pipeline. So the pipeline has taken 52.93 seconds to complete. And below you will be seeing different spans and child span as well. And you will be able to track at the granular level how much time a process has taken, how much time a sub process has taken to complete. And if it has failed for some reason, we'll be able to see that over from here. And it will increase our productivity. We can quickly find root cause that directly going to that particular process where things have failed or it might have gone wrong, right? So those are spans, child spans. And you'll be able to like monitor everything holistically. So that's the use of the spans. Moving on to the next slide. Each span is associated with a span event. So you can send customized key value pair along with some metadata, right? That can be used for root cause analysis, or any data engineer who looks at this pipeline, if, like in case of a failure. So he will be able to understand from this custom events that has been generated during the course of your pipeline. So this can be any metadata, but it must be in key value pair. So as you can see in one such example for Airflow, right? So we are actually sending the DAG ID, when it was executed, when it execution time is completed, and also the DAG URL is embedded over here. So the developer can directly click the DAG URL and it takes you to the Airflow page. Um, so that is about the pipeline events. The next important thing that I would like to cover is the pipeline monitoring and alerting. So let's say once you have onboarded the pipelines into Axle data, you might want to monitor or track the SLAs within your pipeline with respect to your pipeline's performance, or how much time a particular job is taking to complete, or how much time a particular span is taking to complete, or how much time or you might also want to create some monitors on the events that you're generating. So those things can be achieved through pipeline monitors and alerting. So this is like a simple monitors, right, where you can set up the a monitor on a job based on the duration of the job or pipeline, and you can either go with the user defined or previous execution. So when you give the user defined, you get the ability to set up particular time for this process to complete. And when you can also compare it to the previous executions, like an average of previous 10 executions or 20 executions or 30 executions, and you can compare the performance of your pipeline over time. So that is the significance of the pipeline monitoring and alerting. And it can also you can also set up the severity for this alert, like ranging from critical, high, medium, low, and add any notification channels, right, like email, Teams, Slack, or PagerDuty. So that is the significance of the pipeline monitoring and alerts. So then moving on to the next slide, the final piece is automated data reliability. So once you onboard your pipeline to Axle data, you might want to run some data quality policy or reconciliation policy, or even do a profiling of certain assets, right? So those can be achieved using like a low code approach. So you need not use any piece of code in your pipeline. Once your pipeline is onboarded, you can simply come to the click on the pipeline settings and click on automated data reliability. And here you see, right, you can set up execute automation on completion of pipeline on success. Automation type, you can select profiling or data quality or reconciliation, and you need to select the asset on top of which you want to do this activity, and the execution type. So execution type can be full or incremental. So once you do this configuration, the next time this pipeline is completing successfully, then the profiling on this asset will be executed. And you can do this on job level, span level as well. So based on the completion of a certain job, if you want to do profiling or policy execution, you can obviously do that. So that is the significance of the automated data reliability. So the next slide, so we are here, so we'll be looking at the benefits of pipeline observability itself, how it can help the users in understanding the performance or track the SLAs of their pipeline itself. So these are some of the benefits, right? I'll quickly touch upon all of these topics. So starting from automated data reliability. So we just covered the automated data reliability part, wherein once the user has onboarded the pipeline to Axle data, you will be able to set up the automated data reliability on top of profiling policies. And based on the completion of the pipeline or certain jobs, you it the, the policies or the profile gets automatically triggered. So it requires no code, and you can simply use the UI to set up these configurations. And visibility, once you onboard your pipeline, you get the complete end-to-end visibility, and you will be able to extract all types of metadata or metrics, and you can even custom some of the metadata and send it as events. So you'll get complete visibility, thereby the data engineering team or the platform team, whoever is going to investigate in case of some pipeline issue, they'll be able to understand and find the root cause uh, effectively and efficiently. And the SLA monitoring and alerts. So we within the accelerator pipeline observability, you can configure the pipeline monitors to track the SLAs at the pipeline level, job levels, or span levels, or even event level. So these are the different options that are being available to the users in order to monitor the SLAs. And the pipeline execution comparison. So as I stated earlier, every time a pipeline is executed, the execution history is stored. So the user can anytime compare the current execution with the previous execution. Thereby, it provides a user to understand what has changed between two different snapshots. So that's the main benefit of the pipeline execution comparison. And the final piece is circuit break. So circuit break is really like an important use case amongst like many like customers, right? So with the use of circuit break, you can, let's say you have different layers, different hops like silver, bronze, silver, and gold, and the data is moving from bronze to silver and silver to gold, and you have like an ETL pipeline which is built to do this process. So using the circuit break, we can set up some data quality policies to check the health during the movement of data across different hops. And if the data quality score is not satisfactory at any layer, then the pipeline can be terminated, or like we can use that to decide the state of the pipeline. So that's the significance of the circuit breaker. And in order to do that circuit breaker mechanism, the code refactoring has to be done. So I'll cover this part in during this the topic during the next topic, where I'll be showing you the different ways the pipeline can be observed. So moving on to the next topic. Here I'll be showing you the different ways using which the pipeline can be observed. Um, okay, so starting from the first thing is Accelerator SDK. So we Accelerator offers the SDK in Python and Java. So this is either Python or Java can be leveraged to implement full pipeline controls via APIs, right? So let's say you have a pipeline code written in Databricks, and you want to um, view those pipelines in Accelerator UI. So that can be achieved using Accelerator's SDK. So all we need to do is import the Accelerator SDK packages and refactor your existing pipeline code. And you also get the ability to stitch the lineage. So the data, let's say the data starts from source A, and then like a transformation happens, and then we do a cleansing, and the data is moving to some intermediate layer, and we do some other intermediate job, and finally the data reaches the destination. So this type of lineage can be stitched and built with the help of the Accelerator's SDK. And during the course of this operation, we get to create the pipelines, and we also can add the jobs, the spans, and initiate the pipeline runs itself and send custom events from within the pipelines. So that's the benefit of using Accelerator SDK. And the next piece is observing airflow tags with Accelerator Airflow SDK. So within that, we have three ways using which we can observe the Airflow code, right? First one is full code, where we'll not be using any like external plugin or integration. So here manual setup is required. We'll have to import the Accelerator Airflow SDK and refactor it within your existing Airflow code which actually allows you to observe the complete pipelines within AccelEdge. And this step allows you to do all sort of customizations. You can implement circuit breaker, do any types of data quality policy executions in between, and decide the future state of your pipelines, and also build spans, events, and stitch the lineage. That's a very, very important thing, right? You can see how your data is moving from source A to source B to source C. That's achievable through full code. And using light code, here we will be using the Airflow listener plugin, which will be provided by Axel Data. We'll have to place this plugin within your Airflow environment, and it is a little bit custom code. Since it's light code, we have to use little bit custom code in order to support extra span events or any policy invocations, right? If you want to run any policy on the fly, or do any sort of send any sort of custom span events, then it requires light code, so you can utilize the second option. And the third option is no code, where we will be fully dependent on the Airflow listener plugin. This has to be placed in the Airflow environment, and um, this will just observe the DAGs, whatever is present in the Airflow environment. And we also get some out of the box feature, right? You can monitor the pipeline performance, how much time the pipeline is taking to complete. You can implement the pipeline monitors on top of it, and you'll be able to see the basic spans and events that gets generated with the use of this listener plugin. And recently we also have support for DBT core and cloud integration, so we'll be able to observe the DBT pipelines via open lineage integration. So these are the different ways that a pipeline can be observed in Axel Data. So um, before we move on to the demo, I would like to quickly show you the Axel Data SDK usage and its and deep dive, right? Like how quickly we can enable a pipeline and view it on the Accelerator UI. So these are some of the basic packages that needs to be imported, right? So within the Accelerator underscore SDK, these are the packages that needs to be imported. So first we'll have to import this necessary package, and the next step is the creation of the pipeline itself. So this acts as a template within which you will have your pipeline processes. So the first step is create the pipeline, and each pipeline has a unique identifier. That's what you call as UID. And the names should also be unique. You cannot have two pipelines with the same names and same UIDs. So make sure these things are unique. And we can have custom description for the pipeline, and any metadata can be passed, right? Like who's the owner of the pipeline, or which team, or what is the location of the pipeline code, if it is an Airflow or Databricks notebook, or be it anywhere, right? So we can have those types of metadata. And additionally, we also get to add the context. If you want to add more context to your pipelines, that can be passed in the key values pairs. So this will help in defining and registering the pipeline as a template. And the third step is, in order to connect with AccelEdge, we'll have to generate the API keys, and those keys can be leveraged. See, access keys and keys can be leveraged to connect to the Torch client. So this makes sure that the connectivity with AccelEdge is established. And once the Torch the connectivity is established, we can create the pipeline by passing the payload that we have created. So this ensures the pipeline is created. And in the next step, once we have created a pipeline, we'll have to initiate the pipeline run. So please make sure that the pipeline run is initiated once the pipeline has been created. And uh, in the subsequent steps, we might have different processes or sub processes, like reading from source data, or moving data movement from source A to source B, or doing some sort of transformation or cleansing. So these jobs, there might be different jobs or different functions within your pipeline, right? So you can wrap these jobs with using this create job function. So it will make sure that the white box that you saw on the pipeline graph, right? So that can be created by using the create job function, where you will be passing the unique identifier for the job. So that has to be make sure that the job name and the job UID matches the context of what the job is doing. For example, if you're reading it from a source system, you can have like read data from source, or maybe include the name of the source system as well, read data from source S3. So make sure that it is related to the context, and give the name, unique name to that job, and also pass the pipeline run ID and span. If you remember, each I mentioned that each job should have a span UID. The span UID should be unique as well. So you need to pass the span UID, and the job should be created. So once this job is created, the next step that you'll have to do is, um, you'll have to create job using pipeline run object. So there are two ways, right? So either you can create job using the pipeline object itself, or using the pipeline run object. So these are like two same things, but like different ways using which you can create a job. And on top of this, you can have, you can also send events, right? Like if you remember, I mentioned that each span is used to send an event. So within the jobs you'll have spans, and using the spans you can generate some custom metadata which will give additional context to the users who are actually going to debug or view the pipeline results from AccelEdge's page. So that's about the AccelEdge SDK code usage. Now let's move on to the demo. I'll quickly show you all the features and how the pipeline can be observed. I'll also touch up on the code again, and I'll show you a few pieces. Yeah, so let's move on. So this is the like Accelerator homepage, right? As you can see, you'll be able to see three pillars of the Accelerator data observability cloud. First is pipelines. That is the crux of today's session. And moving on to the next thing, which is reliability. We'll be creating different policies within reliability, and we can also embed those policies and policies result within our pipelines, which is very key. And the third one is the optimization. So which helps in understanding the cost of different the cost incurred in like data sources like Snowflake or Databricks, right? So let's jump to the pipelines. I'll just click go to the pipelines. So it takes me to the pipeline page. And as you all can see, it is listing four different pipelines along with the total number of runs. To see this option, right? So there is 50% increase in performance compared to the. So currently there is no failure. So all the pipeline has been executed successfully. And alerts, so there are no alerts, and also the policies that are embedded within this pipeline. So four policies have been embedded, and one policy is showing as warning, and the other three policies are successful. And you also have the option to filter. So let's say you have onboarded different types of pipeline, right? Like Airflow or Databricks or DBT cloud. So you will be able to filter it based on the source system, and also filter it based on the type of integration that you have done with by using the data reliability policies, which might come from various sources that you have connected to. So you can also filter it based on the data source. And you also have the option to filter based on the pipeline failure, success, running, or cancelled, thereby narrowing down your search, right? And also alert type, policy type, the different types of policies. Based on the different types of policies that you have configured, you can also filter it. And finally the policy status. So these are different filters using which you can narrow down your pipeline search. Let's say you have 100 or 200 of pipeline, it becomes difficult, right? So in that case, you can leverage these filters. And also you have the search search bar, where you can search pipeline by its name, and you can identify a pipeline. And coming to the pipeline itself. So as you can see, there are like four pipelines. So I'll just click on one pipeline example. So once you click on a particular pipeline, this is how the pipeline graph looks like, where the blue color box represents the asset nodes. So as you can see, this is the asset nodes. So it represents the asset nodes, and there are close to 14 assets within this pipeline itself. And this the one with snowflake logo, it represents these assets which are present in the snowflake data source itself, and the others are like the ADLS data source. Um, and if you click on this chip icon, you will be able to see the different job nodes that has been created, or that are present within your pipeline itself. So you will be able to see the different, if a particular is failed, or if a particular job is like something is happening, right? You will be able to see the status respectively along with the time it has taken to complete. And the third is alert. So if based on the monitors that you set up on any of the jobs, if a particular job is taking more time, or based on the SLAs, right, you will be able to see the failures here as well, failures or warning, based on which you can take some actions. So currently there are no alerts that has been generated. And as I stated, you get to see the previous execution history as well. So you will be able to click compare and select any two pipeline snapshots, compare, and you'll be able to compare the status of the pipeline, the span count, error events, warning events, success events, and execution time. So the execution event has gone up by 127 percentage for between these two pipeline runs. And you'll also be able to see the pipeline for these two runs respectively. So that's the use case of the pipeline compare runs. And you'll also be able to see the total execution time the pipeline has taken to complete. So it has taken 22.25 minutes. And the percentage execution time compared to the baseline has increased by 35.47 percent. And now let's try to understand this flow, right? So the data is moving from source apps um, to ADLS file systems, and from the file systems the data is moving to the consumption layer, transactions, customers, and support. And again from here it is moving to ADLS staging layer, and the data again moves from ADLS staging layer to the um, Snowflake staging layer. And finally, the data is moved from this Snowflake staging layer to the um, actually, this is the consumption layer. I'm sorry about that. So this is the consumption layer. The first one that you saw, it's the raw layer. So the data moves from raw to staging to consumption, where we are capturing the churn predictions. So when you click on any of the jobs, right, you will be able to see the asset detail itself. So we have an hyperlink over here. Currently, there are no policies that has been policies or profiling that has been configured on this asset. So what we can do is we can just click on this hyperlink, which will actually take us to the um, asset itself, where we'll be able to see the overall reliability scores for this asset. And when you click on the lineage of this asset, this will show you the complete lineage of this asset. So let's say if something is wrong with this asset, you will be able to see if this particular process has failed, or like what are the upstream process, what are the downstream process. You'll be able to monitor the end-to-end lineage um, of this particular asset. So this helps you in understanding where the data is coming from, right? That is very key, and that's very important. Um, so that is about the assets and job nodes. And as we have covered this, like on the pipeline settings, you can compare the baseline of your pipeline compared to the last 10 average runs of your pipeline, or last 20 or last 30. And if you want to compare the average of only successful runs, you can include this checkbox. And the next one is configure monitoring policies, where you can simply add a monitoring policy. You can either do it on the pipeline, entire pipeline itself, or job level. And when you click on job, these are the different jobs that we have within the pipeline, right? These are different steps that are happening within this pipeline. So you can do it on jobs or spans within the pipeline, or even events. So when we do it on job, we can just click the particular job, add metric. So you can either check for the job duration, or job start time, or job end time. So if you know particular job should start at 9 o'clock on a daily basis, then you can use the start time. Or if you know when it should complete, you can use the end time. And or if you want to just check the duration, you can click the duration. And user, if it is user threshold greater than or lesser than, you can mention the time over here. And if it is previous executions, you can just simply compare with the previous 10 runs, and include and decide if you want to include only the successful runs. And configure threshold. So if you want to see if it increased by a certain time, or if it decreased by certain time, right? Or percentage. So you can even configure that threshold. And the severity, alert severity is as well very important based on the monitor that you configure on your jobs. And finally, the notification channel. So once you have the notification channels created, you can come over here and add your notification channels. So let me just save this. And the final piece is automated data reliability, right? So here, what it helps us to do is, once we have onboarded the pipeline, you can set up some policies. So what I will do is, I'll just click execute automation on the successful completion of pipeline. I'll select automation as profiling, and I'll select the assets. So I'm going to profile. I'm going to profile churn predictions. That is the final table which gets loaded. So every time this pipeline runs successfully, the churn prediction table should automatically start profiling. So I'll click on full, and I'll just save this. So this has been saved. Now let's go back to the pipeline. So let me take you to the actual pipeline code itself. So this is my pipeline code. As you can see, I have imported the different types of Axle data SDKs, right, that are essential in observing the pipelines from your data system. So for this example, I'll be showing the Python code that I've built using the AccelEdge SDK packages. So the first step is importing packages, which is done. And the next step that we have to do is, so I have created different functions, right? Like which is used to establish connectivity to Snowflake, establish connectivity to ADLS data lake storage, which is used to upload the files actually to ADLS itself, right? So those things have been already created. And this is the main function. So I've just created a dummy function to generate data, customer data, transactions data, and tickets. Um, and yeah. So if you see this run pipeline function, so here I'm starting off by initializing the connectivity to the Torch client. Here I'll be passing the secret keys and access keys, which I generate from Data's API management. And once the connectivity is done, the next important step that we have to do is pass the pipeline UID and pipeline name. So this must be unique. And you can also pass the pipeline description along with the metadata. So metadata, I've passed the name, role, and what code I have used to build the pipeline. And moving on to the next step, where we'll have to, based on the the pipeline values that we have hard coded, we have to create the pipeline itself. So this code is used to the create pipeline function is used to create the pipeline as a template. And once it is done, once it is established, actually passing that to create this pipeline. So it will create a pipeline view in the catalog service. Once we have created a pipeline, we have to initiate the pipeline run. So that make sure that we have a pipeline created and it is successfully it is actually ready to run. So this pipeline this has to be used to initiate the run. And we can also define a route span for our pipeline. So the route span is nothing but the total time the pipeline is taking to complete. And the next step that you see over here, I am actually creating a job using the create job function where each of the jobs should have a unique identifier and unique name. So the first name is data ingestion from external apps. This is my first job name. And you have to pass the version ID and a pipeline run ID and the inputs and outputs. So these are the many main important things, right? So for the first job, data ingestion from external apps, what do I give as input and what it gives as output? That's very important when it comes to the building of lineage. So here I am mentioning the inputs. The inputs can be an asset or it can be a job as well. So in case of an asset, you have to mention the asset UID and the name of the asset. So we can, if we have onboarded this asset in Axel data, we can go to the asset and get the asset UIDs from the asset itself. Let me quickly show you how we can get the name of the how we can get the asset UIDs. So we have to go to the data source and click on transactions. So let's say this is the asset that we want to see. I'm just clicking on transaction assets. So this is the lineage that we have to pass if we want to stitch and build the lineage properly. So we can just copy this and go back here and just paste the actual lineage of the asset. So for this data ingestion job, our input is going to be data source dot source apps, and the output is going to be the three assets in ADLS. So this is going to be my jobs like ADLS, customer ADLS raw, transaction ADLS raw, and support tickets. Now, if I go back to Axel Data's page and just walk you through the first things, right? So this is my job, and my input is actually fed by the source apps, and it is giving output to the three ADLS files. So that's the step that we are doing it over here. And we can also pass any metadata, custom metadata that you would like to pass for this particular job. It can be like job specific, or you can even pass the same repeated metadata for entire pipeline as well. And then once we have defined and created a job, you should use the pipeline response which we got when we initiated the pipeline run, and create this job. So it will make sure that the job is created, and we'll have to define a job span for this pipeline run. So if you remember, each of the jobs will have a span. So we are actually creating the span for this pipeline and associating the job UIDs that are necessary for this span. And once we create a span, this is when the time starts ticking, right? So whatever logic we might have in the data ingestion process, we might connect to a data source, and we might read something from the data source, we might store in some persistence, and before moving the data to a different hop, right? So those logics those type of logic should come after the job span, after we have created span. So here you, as you can see, I'm just generating the data and I'm just uploading it to the ADLS. So this is my main function that I'm doing over here. So I'm wrapping it with the use of create job. I'm using the spans to track how much time this particular work is taking to complete. And finally, I'm sending an event from my span itself. So I'm using the job span.send event. And we should remember that the event that we are going to generate should have a unique identifier called your event UID, and also you can pass the context data, right? Context data, it should be in the key value pair. You can customize and pass as many variables as many key value pairs as possible. So I passed data processed yes, and the client time I have given this current time. So once this process is done, it will take the current system time and send it as a key value pair, and also the storage location. For storage location, I have added the actual location of this particular data asset. Uh, of the particular storage bucket. So I have added this thing as well, and this job span dot end. So this is really important. So if everything goes well, you can just end this span, or there are other SDKs available just to abort a span or terminate a span. So you can actually depict the status of each of the jobs and span as well. So that is the first job. In the next job, if you see, it's again the similar thing, right? I am creating a job with a different UID, different name. I'm again providing the context of what this job does. This job basically loads data from the ADLS raw to Snowflake raw, and this UID must be unique. And I'm having my main functional logic over here within my span, and you can again I'm sending a custom event within this span and ending the span. Similarly, you can wrap all your functional blocks using using the jobs, spans, and events, and publish any metadata that will help you in debugging in case a pipeline is corrupted or failing, right? So once you have this template created, the final step that you have to do is um, just give me a second. Yeah, we'll have to end the pipeline span. We'll have to end the root span and update the pipeline status. So pipeline status success and completed. And we can also have some exception management in place. And if at all some process is corrupted or some process is failing, right, then you can make sure that the pipeline status is updated as failed or aborted depending upon the use case. And one other thing is that this using this SDK, you can also trigger any profiling or any policies and get the policies result and use that as the decision factor in deciding whether the pipeline has to complete. So this is completely customizable, and this will also make sure that you have the end-to-end lineage that is built on Accelerator. So I will take you to the Accelerator's page again. And here, as you can see, the each of the jobs that I showcased right on the code. So that is built this white boxes. So you'll have to pass the input and output that it is going to connect to. That is really key when it is coming to implement using the Accelerator SDK. And one final thing that I would like to show you. So I'll take you to a different pipeline, right? As you can see, this is again like a very simple pipeline which is built on Databricks. So the data moves from source apps to bronze layer, and then from bronze to silver, and from silver to gold. And in each layer that you see over here, for example, when I click on sales bronze, so I have defined different policies on the sales bronze, starting from schema drift. So if there are any schema deviations, then you will be notified. So you will be able to see the associated policies with respect to this asset. Similarly, there is like an anomaly, data anomaly policy that has been configured. And every time you run this pipeline, you will be able to see the execution status of this policies, and it will be shown in a color coded format. So here it shows schema drift 1 in green, so that means schema drift passes success, and data anomaly is 1 in yellow color, so it says the data anomaly policy is warning. So you'll be able to see your data landscape holistically, understand what are all the policies configured, how its health looks like, um, on a high level. So that is about the pipeline observability and its benefits and importance. So thanks everyone for